All right, so this next section, 3.4, is all about taking everything you've learned with quadratics and kind of putting it together um, with the graph. So let's take a look at what we're going to do here. So when we talk about the graph of a quadratic, it's always going to be in the shape of what we call a parabola, right? And when we say a parabola, it's a U shape. There are certain parts of it that we need to know. One, this is a vertex, and then two, these are what we call x-intercepts. Okay, so that's an x-intercept and that's an x-intercept, right? Now, when we talk about first, when we talk about these x-intercepts first, right? How do we find them? Okay, well, anytime you are on the x-axis, right? What is your y value always going to be? Y is always going to be 0, right? So you know your x-intercept is going to be a point x comma 0. Then this one would be x comma 0. Okay, so we use that idea that every x-intercept has a y value of 0 to find them. So to find the x-intercepts, right, all we do is number one, we let y equals 0. And number two, we solve the quadratic for x. Remember, with these, we can get up to 0, 1, or 2 x-intercepts. Now, when we write our x-intercepts, we should write them in ordered pair forms, x comma 0, x comma 0. So let's take a look here. Remember, there's three ways to solve a quadratic. One is the square root method. Number two is the factoring method. And number three would be the quadratic formula. And you might have to go back and look at your notes from each of these to help you. So when it says right now, find the x-intercepts of this function, right? So what I'm going to do is I'm going to let y equal 0. So x squared minus 4x minus 12 equals 0. Now I'm going to find the numbers. I'm going to check to see if it's factorable. Are there any numbers that multiply to give me negative 12 and add up to negative 4? Right away, if I think about it, negative 6 times 2 will give me negative 12. Negative 6 plus 2 will give me negative 4. Therefore, this factors out to be x minus 6 times x plus 2 equals 0. So now, x minus 6 equals 0, so x equals 6 is one x value. X plus 2 equals 0, so x equals negative 2. So now my x-intercepts for this would be 6 comma 0 and negative 2 comma 0. Okay, so again, all I did was basically let y equal 0 and solve the quadratic. For the next one, again, let y equal 0, so I get x squared minus 9x plus 20 equals 0. Are there numbers that multiply to give me 20 and add up to this negative 9? And if I think about it, negative 5 and negative 4 multiply to give me 20, and they add up to negative 9. So this would factor out to be x minus 5 times x minus 4 equals 0. So x minus 5 equals 0, x minus 4 equals 0. And now all I'm going to do is solve for these. So x equals 5, x equals 4. So one ordered pair here would be 5, 0. My other x-intercept would be 4, 0. Okay, so that's one way to do it. So now it says the next one, find the x-intercepts by factoring the quadratic trinomial. Then find the vertex of the function. So first off, right, what they want you to do is basically we're going to factor this. So we're letting x or y equals 0. So x squared minus 10x plus 24 equals 0. What numbers multiply to give me 24 and add up to negative 10? That would end up being x minus 6 and x minus 4. equals 0. So right away, when I go to find my x-intercepts, right, if x minus 6 equals 0, then x equals positive 6. So you get 6, 0. Then if I take x minus 4, set it equal to 0, x equals 4 is the solution. So my other x-intercept would be 4, 0. Now what they want you to see here is if we go ahead and plot those x-intercepts, 1, 2, 3, 4, 5, 6, 0, and 4, 0, what they want you to see is that the vertex of this will land directly in the middle, right? So what is in the middle of these two x values? Well, this vertex is going to have, if I take the x-intercepts, 4 plus 6 and divide it by 2 to find the middle, that would tell me the middle is 5. So the x-coordinate of my vertex is positive 5. So now, here's the thing though, the vertex is a point. You have to have an x and a y value. So if we know x is equal to 5, all we do is plug that back in to find the corresponding y value. So y equals 5 squared minus 10 times 5 plus 24. Now, when I go ahead and do that, right, I get a y value that is equal to negative 1. Okay, so all I did is plug this in the calculator exactly the way I see it. Y is equal to negative 1. So right away, my vertex is at 5, negative 1. So you have right now, here are your x-intercepts, and here's your vertex. Okay, let's take a look at the next one. Okay, if I go ahead and factor it, what multiplies to give me 8 and adds up to 6? That would be x plus 4 times x plus 2 equals 0. So if I take each of these, set them equal to 0, and then I solve the equations for x, you get x equals negative 4, and then x equals negative 2. So right away, my x-intercepts here, one would be at negative 4, 0. My other one would be at negative 2, 0. But now we have to go and find the vertex, right? So if I were to kind of sketch a graph here and plot negative 2, 0, negative 4, 0, and here's my parabola, what is the x value that lands directly in the middle? There's two ways you can find it. One, you can clearly see that the x value is negative 3, right? Or you could take the two x-intercepts and average them by adding them together and dividing by 2. Negative 4 plus negative 2 is negative 6 divided by 2 is negative 3. So the x-coordinate of my vertex is negative 3. Now to find my y-coordinate, I'm going to go and plug that value in. Negative 3 squared plus 6 times negative 3 plus 8. When I plug this in and evaluate everything, I get a y value of negative 1. So right away here, my vertex would be at negative 3, negative 1. So you have your x-intercepts and you have your vertex. So for the next one, right, to find the x-intercepts, right, first we're going to factor this. So we would get what multiplies to give you 3 and adds up to 4. So that'd be x plus 1. Oh, that's not good. So x plus 3 times x plus 1 equals 0. When I take each of these out and set them equal to 0, right, x equals negative 3, x equals negative 1. So one of my x-intercepts would be negative 3, 0. So negative 1, 2, negative 3, 0. Then my other one would be negative 1, 0. So now to find the vertex right away, we have to determine, what the x value is. So what x value is in the middle of these two x-intercepts? right? That would be negative 2, right? Another way I could do it is to take these, negative 3 plus negative 1 divided by 2. Negative 4 divided by 2 is negative 2. So the x-coordinate of your vertex is negative 2. So to find the y-coordinate, all we're going to do is plug this in, right? So negative 2 squared plus 4 times negative 2 plus 3 will give me a y value of, right, this would end up being negative 1 again. All right. Now, do not get in the habit to think that it's always going to be negative 1, right? So when we look here, my vertex would be at negative 2, negative 1. All of the examples they give you here, it happens to work out that way. But when the vertex shifts up and down, it ends up being different sometimes. All right, now the next one. To find the y-intercept, okay? So a lot of times, like when we go to look at a graph, if I sketch a graph and I look here, we know these are your x-intercepts, but your y-intercept now is where the graph crosses the y-axis. And anytime a point crosses the y-axis, it always has an x value of 0, right? So 0, whatever y is how you find the y-intercept. So to find the y-intercept here, all I'm going to do is I'm going to say x is equal to 0, and I'm going to plug that in. 0 minus 1 all squared minus 4. That's going to give me negative 1 squared minus 4. Negative 1 squared is positive 1 minus 4, which is going to give me negative 3. So the y-intercept for this graph is 0, negative 3. Now, anytime we have a graph in the form x minus h all squared, right, plus k, the vertex is always at hk. But remember, we think the opposite of hk. So when I look at this number inside here, the x-coordinate of my vertex is going to be the opposite of negative 1. What is the opposite of negative 1? Positive 1. And then my y-coordinate is just at negative 4. So this is my x-coordinate. And if I switch it up, this is my y-coordinate. So now that I know the vertex, I'm going to plot 1, negative 4. Then right away, if I wanted to sketch this, right, my y-intercept is 0, negative 3. Now these parabolas have what we call symmetry, right? If I'm 1 unit over, 1 unit up, to find the other side, I can go 1 unit over, 1 unit up. And right away, I know that this would be the graph of a parabola. Okay. All right, so number 9, determine which function is graphed. Well, first thing I'm going to do is look at the x-intercepts, right? This is at 1, 0. This is at 6, 0. Well, I know the x-intercepts here, it would be 6, 0, and then that would be negative 1, 0. So that can't be it. Here, this is not factorable, right? So the x-intercepts are not going to come out nice. Here, my x-intercepts are going to come out nicer, and that would be x equals 1. That would be x equals 6. So this is a possibility. And now this one here, this would factor to be x minus 3 times x minus 2. Is that going to have x-intercepts of 1, 0, and 6, 0? No. Therefore, this must be your answer. Okay? So always narrow it down by x-intercepts, and then look at the vertex. And even sometimes it's good to go to the y-intercept too. Okay? So compare the vertices of the two parabolas given. Okay? Well, in this parabola, right, a lot of times, like if it's not factorable, you'll have to do something different, right? So another way to find the vertex or the x-coordinate of the vertex is when you're in this form, ax squared plus bx plus c, the x-coordinate of the vertex would be the opposite of b over 2a. So what we would do to find the vertex of this is we would say x is equal to the opposite of b, so a is 1, b is -2, c is -7, right? We would do the opposite of -2, which is 2, over 2 times a, which is 1. 2 divided by 2 is 1. Now, to find the y-coordinate, all we do is plug that in. Okay, so we're going to say 1 squared minus 2 times 1 minus 7, right? That is going to give us a vertex of, or an y value of -8. Okay, so my vertex for this one would be at 1, -8. Parabola B, right? So that's parabola 8. And parabola B, right away when I look at my vertex here, that is at 0, -4. So it says which parabola has a smaller minimum. So anytime we talk about the minimum, right? So anytime we talk about the min or max, we're trying to compare the y value of the vertex, right? And when a parabola opens up, your vertex is the smallest point, which means it's a min, right? And here, if my parabola opens down, my vertex is a max, right? So when they're saying here which one has a smaller minimum, well, this minimum value is -8. This min value is -4. Which value is smaller? -8. So parabola A has the smaller minimum. So I do want to recap some things here because you should be taking a lot of notes, right? Number one, to find the x-intercepts, right? All you do is let y equals 0 and solve for x. Oh. To find the y-intercept, you basically let x equals 0, solve for y, and then the vertex, right? Number one, find x. And then once you find x, plug that value in to find y. And remember, to find x, you can either average the x-intercepts, or you can find the x value by doing the opposite of b over 2a. Okay, there's a lot going in here. Let me know if you have any questions, and enjoy.